So imagine you are trying to click a picture of a moving fan blade. If the fan rotates slowly, you can capture the position of the fan blade clearly. But if fan rotates very fast, all you see is a blur. So you don't know the exact position of the blade anymore, right? So this blur is not because of your bad camera, but because of the limitation in measuring very fast moving objects. So this idea at the atomic level is the essence of most beautiful topic in this world, Heisenberg uncertainty principle. So let's see that. So let's go back in the time. So Bohr imagined electrons just like planets revolving around the sun. According to him, electrons move in a fixed circular orbit with fixed energy. But here is the problem. Electrons are not just planets. They are incredibly tiny, moving at enormous speed and behave like both particle as well as wave. So if Bohr is correct, we should able to pinpoint both exact position and momentum of an electron. Just like we say, the earth is at the distance from the sun, moving with this velocity. But the nature at the atomic level does not allow us to do that. This is where Werner Heisenberg stepped in, right? So let's see what is Heisenberg uncertainty principle. So Bohr is sure about his model. So according to Bohr, we can accurately measure the position and the momentum of a moving particle. But according to Heisenberg, there is uncertainty. Uncertainty means when we do not sure about something, right? So suppose that I say India will win the match today. So there is uncertainty, right? Maybe India will win the match or not, right? So whenever uncertainty is there, probability comes into the picture. So, according to Heisenberg, we cannot calculate the exact position and the momentum of a moving particle. So, we do not calculate P because P is your exact momentum. Instead of P, we are calculating delta P. So, delta P means error in momentum. Similarly, we do not calculate X, the exact position. Instead of that, we are calculating delta X, means error in position. And that's why this formula came into the picture. Delta P dot delta X is greater than equal to h upon 4 pi. Here h is your Planck's constant. But right now we are not going into the deep into the mathematical expressions of Heisenberg. Right now we are just listening the story of the Heisenberg and the quantum model. So this means that the more preciously you try to measure an electron's position, the less precisely you know its momentum, and vice versa. So let's make it very simple. Imagine you are catch a buzzing mosquito in a dark room using a torch, right? If you make the torch very bright to see the exactly where the mosquito is, so the strong light hits the mosquito and changes its path. It's no longer moves the way it was moving before, right? And if you dim the torch so that you don't disturb the mosquito's movement, you only see a blurry idea of where it might be. So you lose clarity of position there. So this is exactly what happens at when scientists try to uh, try to measure an electron. The act of observing itself disturbs the electron. And this is exactly what happens, right? So, means at the quantum level, nature forces us to choose. So we can either know where the electron is or how fast it is moving, but never both perfectly at the same time. So the principle completely destroy the idea of fixed orbit of Bohr model. So instead of electron moving in a neat circular path, scientists like Schrodinger introduced the concept of orbitals, a three-dimensional space region in space where there is a high probability of finding electron, because you do not sure about the electron, we only talk about in terms of probability, right? So thanks to Heisenberg uncertainty principle, now understand that electron do not travel in fixed orbit, but they exist in a cloud like region called the electron cloud model. So this is the foundation of modern quantum mechanics and explain why atom, molecules and the chemical reactions behaves the way they do so. So if we summarize the whole thing, so Bohr failed because it is assumed electron are like planets in fixed orbit, but Heisenberg show that at the quantum level we cannot know the position and momentum simultaneously. This uncertainty opened the door to the quantum mechanical model and the atom, the most successful theory of the microscopic world, came into the picture there. And may, that's the most beautiful part of science. Sometimes not knowing everything precisely leads to us to deeper truths, right? So, at the end, for quantum model, if you know about the quantum, either you are a genius or you are a fool. So, thank you so much.